Hi, everyone. I'm Lauren Pisanik, an OpenSciEd teacher in New Jersey, and here to talk with you about Lesson 8. So this lesson has 3 short investigations in it that the kids love, and we'll talk through some tips and tricks to make it successful in your classroom. Let's think about how we got here. During Lesson 7, we ran a humidity investigation, and we figured out how water vapor gets into the air from many different types of surfaces. But we also know from previous lessons that the air is colder higher in the atmosphere. So in this lesson, we're wondering what happens to that water vapor in the air when we cool the air down. And also, why does that happen? So Lesson 8 is a 2-day lesson with those 3 short investigations across the days, 2 on day 1 and 1 on day 2. The lesson setup videos are really helpful to get a good idea of what the investigations look like, and we'll also go over some tips and tricks to make them run more smoothly. Here's the overview of this lesson. There's 3 big chunks. So students will wonder, investigate, and make sense of what's happening with water molecules through those 3 investigations across both days. Let's take a look at day 1. In the first chunk of the lesson, we review what's happening to water molecules when they evaporate, and then make some predictions about what's going to happen to that water vapor in the air if we cool the air down. So then we try it. And this helps us to figure out that water molecules change state when they're cooled below a certain temperature. And that leads us to wonder why this happens. So we conduct a second investigation, which helps us figure out that water droplets can grow over time as they run into other water droplets. The key sense-making moments occur after each short investigation, and we'll dive into those more closely. On day 2, we work to strengthen our explanations by using magnetic marbles to model water molecules. The students carry out 4 short activities with marbles, and they figure out that water molecules are attracted to each other. When they're moving fast enough, they can break away from each other and bounce off each other. But when they're moving slowly enough, they clump and they stick together. So we figure out a lot in this lesson about water molecules, how they form larger water droplets, and how they change state. We also know that they form when the air is colder, like it is higher in the atmosphere where we see clouds. And this leads us to wonder at the end of day 2, why don't we see clouds everywhere? And it also makes us want to know more about what clouds are made of. So that's where we'll go in the next lesson. Lesson 8 has multiple investigations, but the key moments in this lesson really come in the class discussions we have leading up to and then following those investigations, where we make sense of what we observe. So let's take a look at those. Part 4 follows the first investigation, where we observe liquid water appear near the top of a soda bottle, where it's colder. So with my students, I really like to print these discussion prompts out for each table group and have the table groups talk about them as they're investigating before we have a whole class discussion. As students share their notices, we'll name this condensation. And we'll also introduce condensation and boiling point as the temperature at which water molecules change state between liquid and gas. The key move here is that learning the word condensation doesn't explain why we're seeing these water droplets grow and form bigger droplets over time. So we're going to need another investigation. In part 6, we're going to make sense of our second investigation. So students will have a blast trying to move water droplets across waxed paper. In part 6, we want to make sure they've all observed water droplets coming together when they get close to one another. And it's likely some of them will say they act like magnets. There is a video available of water droplets in slow motion that you can show your students if you need to reinforce this, if they don't all say they've seen it. This is the end of day 1, and we want students to leave thinking about why the water droplets kept growing larger. On day 2, we'll build on these initial explanations. So in part 8, we introduce scientists' idea of intermolecular attractions between molecules. And we explain that it can help to think about water molecules as mini magnets. They aren't magnets, but thinking of them this way can help us to explain what's going on. So this is a great opportunity to make an explicit connection to what we figured out in the cups unit. Say, okay, guys, we know higher temperatures mean faster particle movement, right? So if we shake our container of marbles faster, what would that mean in terms of the temperature? And we take the time to map the elements of our model to the real world before carrying out the marble activity. I do this together as a whole class to make sure we're clear about what we're trying to represent. In part 9, the students conduct 4 mini activities to model the movement of water molecules at different temperatures. After each activity, they pause and they complete a reflection question to help them compare that marble behavior to water droplet behavior. This is a tough activity to manage, and we'll go through a few tips in a few moments. But the key is getting students to think through this comparison. So this is where we'll push their explanations. So for example, how did the results of that collision when you made 2 magnetic marbles, 2 water molecules collide, how'd that change when you slowed down the marbles? And how does that help explain why cooling water vapor can cause condensation? A final key moment comes at the end of day 2, where we set up for our next lesson. Okay, we figured out water droplets can form in the air that has water vapor in it when it cools down. But wait, then why aren't they always forming in the air above us, right? We know it's cold there. So we brainstorm some ideas. I love to do these types of exit tickets as quick Google Forms and then be able to grab some student ideas and show them at the start of the next lesson. All right, let's think how to make these investigations successful. So investigation A requires minimal setup, but the short setup video definitely helps. You already did the hard work of prepping the soda bottles for lesson 7. You only need 1 bag of ice per group, but I always make a double set and keep one in our school freezer for back-to-back classes in case I need to send a kid to go get some more ice. This is a really quick investigation. You want to set a timer to keep your kids on track. Investigation B, kids loved this investigation. Rather than have students work on the same wax paper and blow water droplets towards each other, I actually had them do this all individually. You can have bins pre-made with the materials, maybe for a table group, and then let the kids do it themselves. Wax paper works great, but so do page protectors. They only need a small piece of a straw for this. And this is happening at the end of day 1. And then investigation C with the magnetic marbles modeling water molecules. It's important to know that while this is a short series of investigation, it is loud with lots of back and forth between directions, student activity, directions, student activity. So it's important to think through in advance how you're going to manage it because kids love the marbles. They can go flying. Definitely watch the setup video so you know the movements. I found it most successful when I talk through the whole thing with the kids in advance and model it myself first. And then I'm really strict about the expectations with the materials. A timer will keep the investigation moving. You can also definitely do this as a teacher demo with student volunteers to keep it less chaotic. And it will work just as well. In lesson 8, we add 2 more terms to our word wall, condensation, and also the idea of a condensation boiling point. And we don't create any new posters or additional materials in this lesson. We just refer back to the consensus model from lesson 7. I hope these tips and tricks help you move through the investigations of lesson 8. We'll continue with another short investigation in lesson 9, when we will work to figure out why we don't see clouds everywhere in the air. Hope to see you in the next video.